everyone. This now is an overview of where we're going next. So in the last unit, we introduced states of matter. And what you saw was that the fundamental difference between a solid, a liquid, and a gas is simply the proximity of the particles. So we start with gases that have the distance between particles as effectively infinite, dots on my fingers. And so we have the empirical gas laws because gases' behavior is easy to predict. Now we're moving those particles more closely together and we are creating liquids. And it's the intermolecular attractions between this particle and this particle that keep that substance as liquid, because otherwise they just spread apart and become a gas. So there has to be some attractions between neighbors, and that's why you have intermolecular attractions, and that's why you learned about polarity. Is this particle going to attract to this particle? Now, we're going to move into specifically what we call solutions. And the reason that solutions fit in here well is that most solutions that we care about are water-based. And so water is decidedly polar, and there are intermolecular attractions that hold this water particle together with this one, called a hydrogen bond. And then what we want to do is we want to create something. I'm looking around my office. What would be a good visual aid? We want to take a particle that we would hold between those water molecules. And these are called solutions, solute and solvent. So this is my particle, this is the solute, and my water is my solvent. Now here's where I'm going with this. When we just did reaction stoichiometry, we had molar mass. And that was the way that we quantitated our moles and putting it in a reaction. With gas laws, if you were at STP, you had molar volume. And any ideal gas at standard temperature and pressure had a molar volume of 22.4 liters per mole, and you didn't have to look anything up on your periodic table. I'm looking around my office to see if I have one. Oh, here. Periodic table. Has stuff written all over it. With solutions, you have concentration units, and here's the good news, bad news, depending on your point of view. The bad news is you don't just have one thing that you look up. Molar mass, you just looked up the mass, you added it up. Molar volume, you didn't even have to look anything up. You just had STP, and that meant 22.4 liters per mole. If you're in a different class and you were not at STP, you learned more about what to do, but it still wasn't all that terrible. With solutions, we have a variety of concentration units. So here's my Diet Coke that's now watered down. What is the amount of aspartame in this Diet Coke? What's the amount of caramel coloring in this Diet Coke? What's the amount of caffeine in this Diet Coke? Okay, so we're going to have a litany of units, okay? Percent mass by mass, percent mass by volume, percent volume by volume, molarity, and depending on your class, molality, normality, and equivalence. Ooh. Okay, so you need to pace yourself on the solutions part of this unit. Okay, then what will come next are acids and bases, and because we're at 4 minutes, I'll make another video for that one.